Okay, so in this video, we're going to talk about instantaneous velocity, and this is one of the big differences between Physics 1 and Physics C. In Physics C, a lot of our focus is on average velocity, where instantaneous velocity now brings in calculus to into our problems. Okay, so the instantaneous velocity at any moment is defined as the average velocity over an infinitesimally short time interval. Okay, so this is a couple things here, and what you see is that word instant in instantaneous. Okay, and so what we're going to do is this infinitesimally small short time interval. Okay, so what we're going to do is we're going to decrease the delta t between, or the delta t, and we're going to focus on that. Now, a car's speedometer will show the instantaneous speed. It doesn't show us the velocity because it doesn't give us a direction. But if you want a physical, what does instantaneous mean? It just shows us, we can look down at the speedometer at any point in time and say, hey, we're going this fast. Now, if an object moves at a uniform velocity, and uniform meaning constant during a particular time interval, then its instantaneous velocity at any instant is the same as its average velocity. Now, constant on a position versus time graph, right? That means it's going to be a linear relationship, and the slope of a line does not change over time. Okay. Now, on a graph, the instantaneous velocity equals the slope of the tangent of the to an x versus t curve at that point. So if we just look over here to the right in this, oh, I forgot to. So if I'm looking for the instantaneous velocity, what I'm doing is I'm going to take the limit as delta t approaches 0 of my velocity equation. And what happens is this combination of essentially the limit as delta t approaches 0 of these deltas, that translates to the calculus concept of a derivative. Okay, in calculus, there's two types of problems. There's the slope problem and then there's the area problem. Well, the derivative is the slope of a tangent line at any point along the way. Okay. Now, if I go to this graph, last year we would have been focusing on instant or average. So I'm going to say, okay, what is the average velocity between these 2 points? Well, what you do is I put my 2 points, I connect it by a line, and that gives me the average velocity. So this is how we would find average velocity, right? By finding the slope of this line. What we're going to do now is we're going to look for the slope at a given time. And so what I'm going to do is I'm going to find the slope tangent, right, to, or the slope at a point that is tangent to the curve. So if I'm looking for what is the velocity at 1.2 seconds, right, and this is a position versus time graph, well, that's how I find it, is I make a tangent line, and now I can find the slope, right? But we have a mathematical function that allows us to do that. It's called the derivative, right? So let's look at this, see how this is done in principle. So you got this jet engine, right? We're going to put it on it. It's going to be develop a position time graph that's given by the equation x equals at squared plus b. But for our scenario, here are a and b. They like to do this on the physics C test. And we're going to find the displacement of the engine during this time interval, or from the time interval t equals 3 seconds to t equals 5 seconds. And so if I'm looking at my graph, it's this point and this point, right? So that position versus that position. Determine the average velocity during this time, and then determine the magnitude of the instantaneous velocity at 5 seconds. Okay. So one thing we need to do is we need to write our equation. So it's going to be 2.10 t squared plus 2.80. And so if I want to find the displacement, I can do x at 5, x at 3. So 2.10 times 3 squared plus 2.80, and then 2.10 times 5 squared plus 2.80. Okay, and so I'm going to use my calculator. So it's going to be 2.10 times 9 plus 2.8. And so that's going to be 21.7 meters at 3 seconds. And it's 2.1 times 25 plus 2.8. And it tells me it's at 55.3 meters. So how do I find its displacement? Well, I'm going to do 55.3 minus 21.7. And so it tells me a displacement of 33.6 meters positive. So there's my answer to part A. Now for part B, we're going to find what is the average velocity. So if I'm doing this in terms of average, right? Basically my method is to put, points here and make a line that connects them and find the slope of this line. That gives me my average velocity. Okay. And so for us mathematically, it's just going to be delta x over delta t, but I already know what delta x is because I figured out in part A, it's 33.6, and now my delta t is going to be 2 seconds because I'm going to go 5 minus 3, so I'm going to do 33.6 divided by 2, and my average velocity is 16.8 meters per second. Now, how do I find this instantaneous velocity? Okay, so I'm given the position function, and so what that tells me, let me just blow this up a little bit. That tells me that I'm going to take the derivative of my position function, and my position function is 2.10 t squared plus 2.80. So I'm going to take the derivative of this, and what we're going to do a lot is for some students this may be your first time experiencing a derivative. So we're going to use what is called the power rule. Okay, and we're also going to do the constant rule. Constant rule is easy. The derivative of a constant is 0. So when I want to find my position, or when I want to find my velocity, and I take the derivative, that 2.80 doesn't matter. It's only going to be this part that has the variable in it. So the power rule, if I'm doing the derivative of x to the n, well, the power rule is going to tell me I'm going to bring down my n, and it's going to go in front of the x, right, or whatever I have there. So if I had another number there, I would have to multiply. Okay, so it's going to be n x to the n minus 1, right? And so if I'm doing this 2.10, right, if I'm taking the derivative of that, I'm going to bring this 2 down in front. And so I'm going to do 2 times 2.10. So it's going to be 4.20. And then I'm going to do t to the 2 minus 1, which just becomes 4.20 t. And now all I have to do is plug in 5 seconds for there. So I'm going to find v of 5, right? So I'm going to do 4.20 times 5. And it tells me that at that point, this rocket has an instantaneous velocity of 21 meters per second. Okay. Now, there's going to be more practice with this concept of instantaneous. So if this is your first time seeing a derivative, don't be afraid. Okay.